Let's take a look at this example. First, we're supposed to count how many nodes we have in this circuit. We have 1, 2, 3 nodes. One of them is the reference node, that's why I'm not going to count. And this one I'm going to call V1, and this one is going to be my V2. Next, I'm supposed to find the conductance for each resistance. I'm going to label this by Y because most of the books use Y's. That's why I'm going to write Y1 is equal 1 over R1, where 1 over R1 is the conductance, okay, for this resistance, but we are going to label this by Y. So I have 1 over R1 is equal 1 millisiemens. I have Y2, which is equal 1 over R2, which is equal 1 divided by 3 coulombs, which is equal, okay, so I have 1 divided by 3 exponent 3 is equal 333.33 microsiemens. Next, we're supposed to find Y3. Y3 is equal 1 over R3. So I have 1 divided by 2 coulombs is equal 500 microsiemens. Okay. So next we're supposed to find Y11, where Y11 is the sum of the admittances, okay, connected to the node 1. So I have Y1 plus Y2 because this admittance, my Y1 and Y2 are connected to node 1. So this is equal 1 millisiemens plus Y2, which is equal 333.33 microsiemens. This is equal 1.33 millisiemens. Okay, this is my Y11. Next, I'm supposed to find Y12, where Y12 is the admittance between node 1 and node 2. The admittance between these two nodes is equal to Y2. That's why I'm going to write over here Y2. So we found that Y2 is equal 333.33 microsiemens. Next, we're supposed to find Y22. Y22 is the sum of admittances connected to node 2. So I have Y2 plus Y3, where Y2 is equal 333.33 microsiemens plus Y3, which is equal 500 microsiemens. This is equal 833.33 microsiemens. Also, I want you to realize that Y12 is equal to Y21. Okay, the admittance between node 1 and 2 is equal to the admittance between node 2 and 1. That's why this is also equal to Y21. Next, I'm supposed to find the sum of the currents going to the node 1, okay? So this is the sum of the currents going to node 1. Okay, let me just write over here. So this is equal simply I1, because this is just one current going to this node. So this is my I1, and this is equal 20 milliamps. Next, I'm supposed to find the sum of the currents going to the node 2. So let me write this down over here. So I have sum of the currents going to the node 2. And again, we have just one current going to this node, and this is my I2, which is equal 40 milliamps. So someone is going to ask for what we need all this information. We need all of them to set the nodal equations properly. So the general formula says that we have y11 v1 minus y12 v2 is equal to the sum of the currents going to node 1. Okay, and I have negative y21 v1 plus y22 v2 is equal sum of the currents going to the node 2. Okay, so this is the general formula, and this formula is going to work all the time. So in order to make the long story short, you can use this formula all the time. So we have y11 we found is equal 1.33 millisiemens. Okay, so right now I have to substitute all those admittances by the values, okay, by the numbers, and the sum of the currents also have to simply replace by the numbers. So I have y11 is 1.33 millisiemens v1 minus y12 is equal 333.33 microsiemens v2, and this is equal to the sum of the currents going to node 1, which is equal 20 milliamps. Okay, so next we have negative sign. y21 is equal 333.33 microsiemens v1 plus y22 is equal 833.33 microsiemens v2 is equal 40 milliamps. Please notice that anytime current is going to the node is positive, okay, has positive value. If current would leave the node, you're supposed to put the negative sign, because these two currents are going to the node. Okay, so that's why I keep them positive. So as you can see, I obtain two linear equations, okay, and I'm going to use the calculator to find the values of v1 and v2. So I have 1.33 exponent 3 negative 333.33 exponent 6 negative, and I have 20 exponent 3 negative. Okay, so equals, and I have 333.33 negative exponent 6 negative, and I have 833.33 exponent 6 negative, and I have 40 exponent 3 negative. Okay, so I got V1, my voltage V1 is equal 30.08 volts, and my V2 is equal 60.03 volts. Okay, so I found the node voltages. Okay, so I have voltage V1 is the voltage between this point and ground, and voltage V2 is the voltage between this point and ground. Next, the problem is asking me to find the voltage across resistor R2. Voltage across the resistor R2 is simply the voltage equal to the difference of the voltages, okay, V1 and V2. So I'm going to write this over here. VR2 is equal V1 minus V2, where V1 is equal 30.08 volts minus 60.03 volts. So VR2 is equal 30.08 minus 60.03. This is equal negative 29.95 volts. Okay, so this is voltage VR2. Next, I'm supposed to find the current IR1. IR1. So this is the current which goes through resistor R1. Please notice that the voltage V1 is the voltage which will occur across resistor R1. So V1 divided by R1 is going to give me IR1. That's why I'm going to write that this is equal V1 over R1, where V1 is equal 30.08 volts divided by R1, 1 kilo. This is equal 30.08 milliamps. Okay, so this is my current IR1. Next, I'm supposed to find the current IR2. IR2 is voltage VR2 over R2. VR2 we found is equal negative 29.95 volts divided by 3 kiloohms. This is equal 29.95 negative divided by 3 exponent 3 is equal negative 9.98 milliamps. Negative 9.98 milliamps. Okay, so this is my current IR2. Next, I'm supposed to find the current IR3. IR3 is equal the voltage V2 divided by resistance R3. Voltage V2 is the voltage between this point and ground. So this is voltage across this resistor. So V2 divided by R3 will give me IR3. So I have V2 over R3 is equal 60.03 volts divided by 2 kiloohms. This is equal to exponent 3. This is equal 30.01, we can say, okay? 30.01 milliamps. Okay, so I find the currents. Next, we're supposed to find PR1, PR2. Okay, so I have PR1 is equal IR1 to the second power times R1, which is equal IR1 we found this is 30.08 milliamps to the second power times R1, and R1 is equal 1 kilo. Okay, so this is equal 30.08 exponent 3 negative to the second power times 1 exponent 3. This is equal 904.8 milliwatts. Okay, so we found the PR1. Next we're supposed to find PR2. PR2 is equal IR2 to the second power times R2. Okay, so this is equal IR2 negative 9.98 milliamps to the second power times R2, which is equal 3 kilohms, is equal negative 9.98 exponent 3 negative to the second power times 3 exponent 3 equals 298.8 milliwatts. Okay, so this is the power at resistor R2. PR3 is equal IR3 to the second power times R3. This is equal IR3 we found is equal 30.01 milliamps raised to the second power times R3, which is equal 2 kilohms. This is going to be equal 30.01 exponent 3 negative to the second power times 2 exponent 3 is equal 1.8 watts. Okay, so this is my power PR3. If you want to find the total power, so PT is equal PR1 plus PR2 plus PR3. So I have PR1 we found is equal 904.8 milliwatts plus PR2 298.8 milliwatts plus PR3 1.8 watts. So I have P total equals 904.8 exponent 3 negative plus 298.8 exponent 3 negative plus 1.8. This is equal 3 watts. Okay, this is my total power, and at this moment I can say that the problem is solved.